Hello, my name is Tudor Giano, and I am from the Department of Computer Science at the University of Liverpool. And today I'm going to go through the work of reducing tactile Sim2Real domain gaps via deep texture generation networks. This work has been carried on by myself, by Daniel Fernandez Gomez, and by Dr. Shan Luo. First and foremost, our work relies on the recent developments of tactile sensing images, and more specifically on the simulation of those. The top row of the image, we can observe the real images gathered by the interaction of the gel side sensor with objects manufactured by a 3D printer. On the second row, we can observe the simulated images that have been gathered in a simulated environment. Those images present several differences, most notably the texture and artifacts that were injected by the 3D printer, for example, scratches. Our work aims to diminish the gap between the simulated and the real images by injecting those artifacts into the simulated images. Our framework relies on the cycle GAN architecture, where we take our simulated image, we map it to the domain of the real images through a generator, and then map it back to the domain of the simulated image through the second generator. We compute the adversarial loss, and we compute the cycle loss accordingly. Furthermore, because we discovered that the cycle GAN architecture gives rise to different anomalies, such as a flipped background or in contact regions being generated where there is not an in contact region, we added an additional loss, a mask loss. This mask loss is developed by using the depth map to create a binary mask, which we use to cover the in contact region, thus allowing us to perform a loss between the adapted image background and the simulated image background, and the adapted image background and the real image background, thus giving rise to our mask loss. Our results summarize as follows. First of all, in the first column under the cycle again, we can see those anomalies. We can see that the background is flipped and that the in contact region was generated, whereas ours does not create such anomalies. Secondly, we trained a classification model on the simulated and generated images respectively, and tested on the real images, resulting in a gap of 0.81% for our model. And lastly, we compute the structural similarity index metric as well as the mean absolute error, resulting in our model having the greatest SSM while having the lowest mean absolute error.